Hello, when is July 14th? Alright, so this is the latest round. I coded up essentially the solution from this one, right? I coded up and was trying to see if it works. I submitted, but I passed quite a lot of tests, but we got one wrong. I think we need to take a closer look. I did run some debugger and try to see what happens here. It could be, some mess up. It's possible, but we'll see. So we'll leave it as is, and we'll go with whatever it's gonna be for today. Oh, I think we have a chance to revisit that problem again. Valid word. Minimum of 3 characters. Only digits and English letters, upper and lowercase. At least 1 vowel. At least 1 consonant. You're given a string, word. Return true if word is valid. Otherwise, return false. So I just go through to check. It's like a password check, right? So it has to be size of 3. Has to contain it didn't say it has to contain a digit. It just at least 1 vowel and 1 consonant. So 1 vowel, 1 consonant. 1 vowel, 1 consonant. Only, yeah, this is a false because of this. So we just get a 1 vowel, 1 consonant. Let's do this. I want to see if it's necessary to always include a digit. I think it's not. Yep, it's not. You don't have to. Okay, so we just code it up according to the rule, exactly the rule. Hopefully we get all the rules in. So first we'll check the size, then we will go through. How are you going to check if it contains? Well, I will have AEIOU upper and lowercase. Well, we'll check. We'll check. So digits, English letters, that I can check. But how about AEIOU? But we want at least 1 vowel and 1 consonant. Okay, so we can say what's the string? C plus string contains char. Find. I wonder if there's a better way. So we need to check if it's a vowel or if it's what would be the best way to check? I'm gonna go with this. Yep. Yeah, we're gonna do this AIOU thing. And then, actually, I think I can first start with say if size is at least 3, right? Yeah, it's smaller than 3, turn false. Okay. And for char of word, if is there any way to check char is numerical, is digit? Okay, alpha numerical, is alpha numerical. I knew it. So C type. So we can do this. Alright, C. If it's not, right, then we'll return false. If it is, then we need to count. So vowel count, consonant count. Okay, we need both counts. All right, now we're gonna say is if is numerical, is number, right? Is numerical, is digit. Alright, if is digit, then we'll continue. Otherwise, then it's alpha. You know what? I think maybe is letter. I think it's just alpha. Is alpha. Maybe that would be better. So we check this one first, right? So we know this one is fine. We will just always continue this thing. Alright, we can say else if is alpha. Right? Then we do something. And then else, now this is going to return false. Right? So here then we can say size t position shall equal to vowels dot find C. Alright, we'll do the find, and if it's not the end, then we found. Right, we can say if position is not equal to vowels, oh wait, hold on, std string the no op. If it's not, then vowel count, else consonant count. Okay, so now we go through everything. Then we just need to check if vowel count is larger than 0 and consonant count larger than 0. We will return. So I can just return this. Alright, we'll return this. Okay. Let's see if we considered all scenarios. Should be. Yep, we considered all scenarios. Of course you can do that. Of course you can to lower. Yeah, that's also fine. You don't need a counter, you just need this. That's true. Alright. That was good. Now we have to go back to this one. That was, I think, so I think it's 1 1 21 95. This is yesterday, right? So what we're gonna do is we will n. Actually, we don't have this. N equal to 5. First player, I remember, is 1. Second player, remember, is 4. Okay. Then we'll do sol dot root. No, that's not true. Earliest. Alright, where do you stop? I think I need to stop at the beginning. Okay, I always stop here. Okay. Let's see. So n starts with 5. Right, 5 1 4. Hold on, 5 1 4. So 1 2 3 4 5. And then first player, second player is here. So I need to swap, so it should be 1 2. Mid should be 3. F, no, S, yes. So S, yep. F is 1, S is 2. So now we're going to do state. So state start from 0. N is 5, so the mid always go through. So state always going to be 1. Okay. 3. So 3 minus 1 is 2. So yeah, so the first one shall be 7. Yes. The number of next f, next s, and set bit. Okay, so we have first, it's not equal to 0, that's true, so set bit count. I equal to f, yes. So next will be 1. Next one, yes. I not, but this one, s is equal. Yes. So next f is 2. Yeah, it's 1, 2. Oh, yeah, we can do memoization actually. We actually should do memoization. Yeah, the third one, but we don't do anything. Done. Right, so now we just have 1, 2, and a mid. Right, so we have 1, 2, mid, so basically we have 1, 2, and 3. It's the second round, it's the first and the second. Yeah, this one will, no matter how you do it, it will need 2 more steps. Right, we have 1 step, so that's 3. So what is a scenario where we can do 2? Oh, I think don't move is here. We just start with this. We don't move. So after 1, this one comes through, this one lose, and this one wins, so we get to a 1, 3, 4 scenario. So 2 steps. So we don't shift them here, we keep them there, but we still do this. Right? We still do this. Well, we just need to set. I see. So if someone's on the right hand side, we're going to set a prime position, right? And then that prime position has to be a 0. Right? That prime position has to be a 0. And then we'll go through then the prime position. Oh, okay. Oh, it's actually more complicated. Alright, so we need a prime. So we need a FP, right? FP, F prime. So start value is going to be negative, S prime, negative, right? So if this, then we have F prime. If this, we have S prime, right? This is still fine. This is fine. First player always wins. Now that depends, right? That depends. So for first player, we shall say if f is large, if f is small or equal to mid, then we do this, right? And in fact, let's put it here. Else, then we need to guarantee state. How do we guarantee this position is going to be 0? I actually don't know. No, I think it will, because we start, hold on. So we need to set something to be 0, which means everything has to be 1 except for that to be 0, then we can OR them, right? Or we check to see if it's already 0. If it's already 0, then we don't do anything. Yeah, if it's already 0, then we don't have to do anything. If it's not 0, then we do exclusive OR, right? Else, then we else if, right? Else if state and something is not equal to 0. Right? Then we'll say state exclusive OR 1 left shift mid minus f prime. Right? Mid minus f prime. So that's how we get that to 0. But here, what is this? This is going to be 1 left shift mid minus f prime. Right, so we do this trick to ensure that it's going to be 0. And then we'll do exactly the same thing here with s. Right, so we say s is smaller, then we'll always do this. Otherwise, if s is not equal to 0, then we will guarantee it to be 0. So that's good. Okay, so that's that, and then we'll count. Right, we'll count. This is fine. It's not equal to 0, set bit. Again, we say if f is smaller or equal to mid. Right? If f is smaller or equal to mid, Actually, no. I think I just say if this is equal to this, or I is equal to f prime, then it's next to s. Otherwise, we say I equal to s prime, then that will be the next this. Okay, let's try. It's just slightly more complicated, and I do think DP will make it even faster. Oh. Did we actually don't know how we get this? I'm not sure. I am not sure. Huh. Oh, I see. Oh, it's actually a little bit hard. Um, mm, think? So like in this scenario, basically this is going to be a 1, this is going to be a 0, this is going to be a 1. So this is the default, right? 1, 0, 1. But how do we know where the second player is going to be? Huh. Because this one lost, right? So I actually have another 1 in this position. Oh, holy moly. I think we need to expand it. We need to expand it. Right? Basically, we have the state on one side, and we need to mirror it on the other side. Right? So, like here, it's going to be a 1, this is going to be a 0. So essentially, we're going to do a exclusive all of all ones, right? Exclusive all of all ones. How do I create this entire thing just based on the left half? We can. So this is fine. So what is not fine is this part, right? Need to create the state of the entire n, right? Entire n. Then find the next f and next s. So I have the current state, right? Then we need to expand this state. How do we expand this state? We actually need to say full state, okay? Full state equal to current state. And we're gonna go from right to left, okay? Right to left, and or decide where we should go first. And then we will left shift end, right? So int index shall equal to 0 or 1, and that depends on n mod 2, right? If n mod 2 is even, then we start from 0, otherwise we start from 1. And while index is smaller than mid, right? So if it's 3, mid is 3, and I start with 1, then we'll go to 2, then that's it, right? So we're gonna get, first we're gonna get is the bit. So the bit is going to be state and 1 left shift index, right? That's the bit. And we're going to say the target bit is this, then exclusive all 1, right? That's the bit. And then what we're going to do is full state left shift 1, right? Full state left shift 1 and the bit, and assign this back to full state. for loop index equals n divided n mod 2, index smaller than this, and index plus plus. So I don't need this one, we don't need this one. So this will give you the full state. And this, we're gonna go to all n, right? And then this is gonna be n minus, right? N minus. And then we say if it's not equal to 0, we do this. And here we don't need the prime, we just need this, and we need the s. Okay, I'm not sure, but we're making a little bit change, and hopefully this will work. Oh, that does not look promising. I feel like we have to DP regardless. It's essentially the state, right? It's essentially the state. So if we want to DP, we need to put, so we have this N, F, S. Yeah, we have to get a DP to return number of round. So given this, how many rounds? Oh, so we have to use DP. But before we do that, I just want to make sure that this one works for this. This shall be able to do. Oh, this is also not able to. Huh. I am surprised. I don't know why. We did extend it, maybe that's why. Oh well, there's a little bit more complicated, but next one's just make this into a DP array. Yeah, just a DP array. I don't know, is there any better way to do this? Yeah, a DP array. DP array, then we need 2 DP arrays, right? Because I need to know, given this, what's the largest and what's the smallest. So we get 2 DP arrays. Oh, the journey is not over. The journey is not over. Okay, I'll try it out another day.